This class is designed to help the student of class 10 and we are continuing chapter 4 and today's focus is on the factors which affects acceleration due to gravity. Acceleration due to gravity small g. Now I want to recall 2 points. Number 1, definition of acceleration due to gravity, and number 2, I want to just recall, if you don't remember, look at that lecture 2 where I proved g is inversely proportional to square of the radius of the earth. Now let's talk what is acceleration due to gravity. When a body is dropped, then every second its velocity goes on increasing like this. When a body is dropped from certain height, first its velocity is 0 when it was in our hand, 0 meter per second. At the end of 1 second, its velocity is found to be 9.8 meter per second. At the end of another 1 second, or at the end of second, it is found 19.6 meter per second, and at the end of third second, it is found 29.4 meter per second. What is the difference? Every 1 second, in every 1 second, its velocity is increasing by 9.8 meter per second. Here also it is increased by 9.8 meter per second. 9.8 meter per second. And that's why, what is the conclusion? If every second its velocity goes on increasing by 9.8 meter per second, then the acceleration produced on this body will be 9.8 meter per second square. This is the value of acceleration due to gravity. And this is the acceleration produced due to the gravity force of the earth. That's why named acceleration due to gravity. But this value is not same in all the places of the earth. It is different in different places of the earth. The difference is a little, but it is different in different places of the earth. And in previous class also, what I told you, this acceleration due to gravity is inversely proportional to the square of the radius of the earth. If radius is more, g will be less. If radius is less, then g will be more. Okay, after this much understanding, I want to bring you back to the major point which we focus on this class. What are they? Factors which affects the acceleration due to gravity. What are the factors? Look at this. Number 1 factor, acceleration due to gravity is affected by the radius of the earth. Number 2, height from the surface of the earth. Number 3, depth from the surface of the earth. Number 4, rotation of the earth. Among these 4, the first one is highlighted in our syllabus. That's why I'll talk about this first one at last. First, I want to finish second, third, and fourth. And then I'll come back to our main focus, radius of the earth. Now, acceleration due to gravity is affected by height from the surface of the earth. Let's say this is earth and this is earth's surface. And if we go to the height, greater and greater height, then what is found? Acceleration due to gravity is highest on the surface, that is 9.8 meter per second square. But when we go to more height, it becomes less, maybe only 9 and then 8 meter per second square and 7, 6, 4. This way, when height increases, acceleration due to gravity decreases. What is the reason? Reason is very simple. Because when the distance of the object from the earth increases, then the force of gravity or attraction force of the earth decreases. When distance increases, attraction decreases, and because of less gravity force, acceleration produced due to that force will be less. That's why when height increases, then acceleration due to gravity decreases. Now, second point, acceleration due to gravity depends upon depth from the surface of the earth. If we go to the greater depth inside the earth, then what is found? Acceleration due to gravity g goes on decreasing again. It is maximum on the surface. It decreases as we go to height. It decreases as we go inside also, and it becomes 0 at the center. This way, acceleration due to gravity is maximum on the surface. Okay. Now, number 4, it depends upon radius of the earth. Rotation of the earth. What it means? Do you know that earth is rotating around its axis? It is rotating around its axis. It rotates from west to east. Because of its rotation, every object lying on its surface is also rotating. And a centrifugal force acts in the opposite direction than that of the gravity force, which reduces the gravity. And that's why the acceleration due to gravity becomes less than its real value because of the rotation of the earth. Okay, now I want to bring you to the main point, which is focused on our syllabus. In our syllabus, look at this, radius of the earth. There are many questions which is related to radius of the earth. I mean to say acceleration due to gravity is related to radius of the earth. Now, first question. G is more at pole than equator. Why? This may be an important question in examination. Why G is more at pole, less at equator? Do you know that earth is flattened at pole, bulged at equator? Like this. I made this earth which is flattened at pole, that's why radius at pole is less. Radius at equator is more. This polar radius is less. Equatorial radius is more. Earth is not a perfect sphere. We can answer this question this way. Earth is not a perfect sphere. It is flattened at pole, bulged at equator. That's why polar radius is less, but equatorial radius is more. And since G is inversely proportional to square of the radius of the earth, so G is less at pole, inversely proportional to the square of the radius of the earth. That's why R is less at pole. That's why G is more at pole. And value of G is found 9.83 meter per second square at pole. But radius is more at equator. That's why G is less at equator. It is found 9.78 meter per second square at equator. It's clear, isn't it? Now, let's go to second question. Why G is less at the top of the mountain than the bottom? Now, let's imagine here is a mountain. And radius of the earth up to the top of the mountain is more. But radius of the earth up to the bottom of the mountain is less. This is the key point. That's why question is why G is less at the top of the mountain than the bottom of the mountain. We can answer this way. Radius of the earth is more at the top of the mountain than the bottom. And we know that G is inversely proportional to the square of the radius of the earth. Since radius is more at top, G is less at the top and more at the bottom of the mountain. Now let's go to third question. Why G varies from place to place of the earth? The similar way, we'll answer the same way. How? Earth is not a perfect sphere. It is flattened at the pole, bulged at the equator. That's why polar radius is less, equatorial radius is more, and its radius is different in different parts of the earth. If radius is less, G will be more, because G is inversely proportional to the square of the radius of the earth, and if radius is more, then G will be less. Thus, G varies from place to place of the earth. Now let's talk about fourth one. Why a body falls faster at pole than the equator? This can also be answered in the same way. Why a body falls faster at the pole than that of the equator? Earth is flattened at pole, bulged at equator. Polar radius is less than equatorial radius. Since G is inversely proportional to the square of the radius of the earth, radius is less at pole, so G is more at pole. And because of more G, the rate of fall of the body will be high, and a body falls faster at pole than that of the equator. This way we can answer all these questions which are related to radius of the earth.